Welcome. In this video, we're going to sketch a graph of the curve defined by this vector valued function. And now we see a cosine and we see a sine, and it's tempting to think circle. But if you notice, these values are not the same. What this tells me, since these values are not the same, is that I have an ellipse, and I have an ellipse in the xz plane. That's what these tell me. And notice that y varies. So this is actually an elliptic helix. So let's get a basic idea of what this looks like on the three-dimensional coordinate system. So please take a moment and sketch your three-dimensional coordinate system. Okay, here I have my three-dimensional coordinate system. And remember, this is an ellipse in the xz plane. That means this is going to curve around the other axis, the y-axis, because y just varies as t does. So that's what it's going to look like. And it's going to be a little more squished. And it might help, actually, if I sketched what this looks like in the xz plane. So there is our xz plane. So along the x, we'd have 9 to negative 9 here. And along z, we'd have 2 to negative 2. And the ellipse in this plane would be squished in this manner. And there's my not so great attempt at drawing an ellipse. There, kind of looks a little better. And so now when I go ahead and sketch this here, I want to make sure it goes further out along the x-axis, and it's more compressed along the z-axis. So along the z-axis, this would go up to positive 2. Along the x-axis, we'd have 9 and negative 9. Okay, so here is the sketch of what this looks like, two-dimensional in the xz plane, and here's our three-dimensional sketch. Let's use technology to improve upon this curve. Okay, so now we're going to take a look at this using technology and compare it to our hand-drawn sketch. So please take a moment and open up the vector value function 3D grapher. It is in a separate tab here within the Canvas guided lecture. You can also find it in the video description. So let's go ahead. Not 99, excuse me. We're going to type in 9 cosine t. And then for our y value, we're leaving it as t. And then for our z, 2 sine t. And I'm going to go straight to show curve right there. And let's zoom out and rotate a bit. And we can see our vector is pointing to it here. And we can also, oops, let me move our y-axis label here, our z-axis label, and our x-axis label out of the way. If we look in the xz plane, as we discussed, we have an ellipse. And we can see here 9 along the x-axis and positive negative 2 along the y-axis. Z-axis. It's squished down along the z. But in 3 dimensions, it looks like an elliptical helix. And I'm going to go ahead and change this lower bound to negative 50, upper bound to positive 50, and we can see it continues on for a while. You can also play around and trace this t here. And what that will do is it'll show you where the vector is at any point for t, where the vector is pointing. And remember, our vector valued functions are defined by wherever this tip is in 3 space at any value of t. So right now when t equals 10, our vector is right here. And then as we change and go down towards 0, it continues tracing out points. And when we are here at negative 10, our vector is pointing right here. So this is where our curve would be defined for that value of negative 10. I hope you found this video helpful.